Mary joining, so that was the only reason cautioned
Okay,
on holding up.
sure. All right, shall we go to the next slide then?
Okay.
So this is our very first ORCA community group meeting. So I'd like to welcome everybody here. It's online virtually, so I'd like to hear feedback afterwards, how it went from your end, and if this is a good forum. And so the idea here in this presentation is to introduce you to this community group and bring you up to date on what's going on with the ORTC API, and hopefully make some good progress on some outstanding issues, and then refine anything that is kind of rat hole-ish or details to the forum and to the list, and go from there. So next page. So you already are here, so you know the Hangout URL. The slides will be published to the ortc.org website, so you can get the slides afterwards and view it. We'll also have a link up somewhere regarding that. Anyway, next. And just so I introduce myself, Robin Raymond from Hookflash. I'm the chair of the ORCA community group and the current ORTC spec editor. So I think it's important we just go over briefly the difference between a community group and a working group, and I want to describe what the IPR policies are for the community group. The community group is basically a collection of enthusiasts coming together and trying to come up with some kind of technology that we're eventually, hopefully, will become, or potentially could become, something that goes into the working group, but doesn't need to. The IPR rules are slightly different. As an editor, I have to take things that have been cleared for IPR, meaning that people have to agree to the community license agreement. And there's a few ways to do that. One is you can join the community group and therefore agree to the community licensing agreement, or you can specifically give a community license agreement statement for a piece of work that you're contributing to the group. And the idea here is that it allows us, for this community group, it allows us to rapidly develop a specification, and we can get a royalty-free specification, which is really important. And the contributors can know that what they are giving is only the contributions that they want to give to the community group, and it's completely transparent because it's out there for everybody to see. Anybody is allowed to post to public ORCA. You do not need to be a member of the community group. That's why it's called public. The best thing to be clear about what you're contributing is when you want to contribute an idea or concept to the specification, what you should do is you can send it to the public list for sure, but you should also CC the public contrib if you're a member, and only members can post that list. Next slide. These are some important links. So the ORCA community group website, that's the link right there. You can see it in the slide. The public mailing list is public-ORCA, and anybody can contribute to that, and only members can contribute to public ORCA contrib. Okay, next slide. Another important website, we're going to everything to do with the specification and everything around ORTC. We're going to publish all the updates on the ortc.org, and that's going to be more than just the specification and more than just the community stuff. So anybody who's contributing to the public repos that we have, we've got some public source code that we're working on, some open source projects that we're working on collectively, and that's all there, and linked all there. So, and when we actually do the management of the editor's draft, we use GitHub to manage all the issues that are outstanding. So I take contributions from the list, we create issues in GitHub, and then we modify and update specification using GitHub, and then we eventually publish it from there. Continue, please. Next slide. So the current status, if you go to ortc.org and you don't want to type that long URL, you'll see a link on the right-hand bar to the current editor's draft. You go to ortc.org. And some of the important changes that have come down since the earlier January version. Actually, there's been a lot of changes. We split the RTP connection object from being this big object into more of a pipe model where you have data coming into the pipe and going out of the pipe. So it's a little bit different a flow. Instead of having one master controller, you've got a flow, and there's going to be a couple slides down. We'll have a big picture overview of that, so I don't really want to get into that in too detail. We also have split the RTP sender and RTP receiver objects so you can control the sending and receiving parameters per track. And part of the debate is going to be on this topic, how we do that, so that's coming later. We split the ICE and DTLS into two independent transports. The idea is that although those are the only transports right now, there might be other transports in the future. We've added an SCTP transport for the data channel to derive from that. We have added an RTC RTP header extension parameters, so you can describe some additional header stuff for RTP. We've added an ICE listener, and that allows you to do parallel forking because of that object. And there's DTMF support that's been added. Well, it used to be there, it got taken out, and then it got added back. So, next slide. Okay, so this is the big picture architecture. It's kind of an object/pipeline model. So just to walk briefly through it from one side to the other, you start off with a media stream track on one end, which gets wired to the RTP sender, which describes how to send data over the wire, which the data ultimately gets sent over the DTLS transport. Because it needs to be encrypted and decrypted, which goes over the ICE transport, which is responsible for maintaining the connection between you and your peer and discovering all the candidates. And then ultimately the ICE transport is wired to an ICE listener so that you can wire more than one ICE transport to the same ICE listener and therefore using the same credentials for all your ICE candidates. And then on the other side, it just demuxes in the opposite order, which is going through from the ICE transport to the DTLS transport to the RTP receiver on the receiver side, and then out comes a media stream track on the other end. And of course, the data channel is the same thing, except it goes to the SCTP transport instead of the RTP sender and receiver. Next slide. There are some knowing loose ends that we have to clean up. So one is that the data channel is wired to the DTLS transport directly, and it should be. It should be wired to the SCTP transport. And there's a few examples in the specification that are just completely blank and are missing, and so obviously some examples need to be in there, and I'm sure some of the examples need to be cleaned up and vetted. We haven't added in the DTLS fingerprint and identity stuff. We know how that should be modeled. We just haven't taken the time to actually implement it in the specification yet. For the most part, I think we do. And of course, there might be other glaring things that other people have noticed that are outstanding. Obviously, error is another one. Errors itself as an object, how do we manage errors and that kind of feedback? And stats is something that is just a big black hole that we have to define as well. Next slide. So before I continue, I want to make sure that everybody in this community group is liking the way we're heading in here. If there's any big concerns over the pipeline model that's been proposed regarding that versus using some bigger object, or if anybody thinks we should be doing something entirely different, now is kind of the time to speak your mind. And I'm hoping everybody just loves it. I'd love to see some thumbs up or something if everybody's happy, because if they are, then great. Bernard gave his thumbs up, so we're good. Good enough for me. All right. Next slide then. Okay, so error handling is something that's just an ongoing discussion. There's lots of issues regarding using promises versus feedback on the object, and the error has error states, or there's a whole bunch of different ways to do this. So we really have to get this error handling handled. And there's some talk on how to do CSRC management when it comes to active speaker information, so that ORTC could be used in let's say, an SFU, a selective forwarding unit scenario or something like that. So there's some discussions on how to do that, and whether you do it in polling or callback mechanisms. So if you're interested in that area related to RFC 64 or 65, then by all means go to the list and let's talk about it. This was not one of our original goals when we set up to do ORTC, but this was again a contribution. I think it's a valuable one. I would just caution that we're trying to come up with our version 1.0 spec. We're not trying to take care of absolutely every scenario. So some things might make it in if they're really good ideas and they're easy to get in there, and other things might just have to wait, depending if we can come up with some resolutions that are, fast enough. Okay, next slide. Another thing is when it comes to RTP listeners, the RTP listener object, which is not the ICE listener. There's a difference between RTP listener and ICE listener. An RTP listener is all about handling those unhandled SSRCs that come in and you don't know, you haven't mapped any RTP receiver yet. How do you handle that? How do you create a new object? What do you do? How do you buffer the data that's there? Do you buffer the data there? How much do you buffer? What kind of callback events do you need? All that kind of stuff. We're trying to discuss that on the list right now to get that going and get that object refined. And one of the things that we hope to cover today is the RTC-RTP parameters object, which is to describe how you intend to describe media in the RTP senders and the RTP receivers, so that you can define the codecs, the layering, simulcast, all that kind of good stuff inside of a framework that makes sense, and what level should we be targeting. Next. Whoa, too many. Okay. So these are the issues that I'm kind of hoping that we can get through today. Some of these I'm hoping are non-controversial, so we can just rubber stamp them and continue. The RTP sender receiver, I think, is probably the biggest thing of all, so I'm hoping that we can get through the upper issues fast so that we can get to that one and really discuss it and use the remaining time towards that. Next. So, DTMF support. You can see the current DTMF API in the latest editor's draft. Again, that's on ORTC.org. The link is up there to the specification. And it's basically modeled after the WebRTC 1.0 specification with some slightly different wiring because we have different objects. But aside from that, it pretty much follows the modeling with the same RFC 4733 model. I don't know if anybody has any issues or concerns they want to bring up regarding DTMF. If not, I'd love to just rubber stamp it and continue, or any details they can certainly be brought to the list. So everybody's happy with it, just give me a sign, thumbs up or something, and we'll continue, or speak your mind. Yeah, nobody's, okay, good. Next slide then. Data channel. The problem right now, there's two problems. One is that the data channel is wired to the DTLS transport directly, and it shouldn't be. It should be wired to the SCTP transport object. The reason being is that you want a creator object because there is a concept of max data size that needs to be attributed to the transport, and you don't necessarily want to you want to wire it to that object to have a little bit of a cleaner object model. I don't think that's controversial, but if anybody thinks that is, then please speak your mind. The other issue we had was people had questions. I think that's the next slide coming up, so maybe I'll leave it to the next slide.
Robin, can you just kind of explain? I didn't quite follow exactly what you're saying there around the whole max size stuff and how that interfaces with this issue.
The transport object does have the concept of a max. The data channel SCTP transport has to have a max size for the transport because there's no concept of streamed data. It's not a stream that you're sending to the other side. It's like a packet. So it's a package of information in an object that you're sending as bytes to the other side. As such, it's not really related to the object. It's just that you have to know that before being able to send your data. That is a requirement. So you absolutely need to have an SCTP transport object. And if you're going to have an SCTP transport object containing that information, you might as well wire your data channel to that. And also for your receiving of data channels, you want to be able to receive the on new data channel events. You're going to want to have that object for that reason as well. So it just makes sense from a pipelining to wire your data channel to that object as opposed to directly to the DTLS transport for consistency for the incoming stream, because you want to have the outgoing stream going to it as well as the incoming stream, as well as for having the size object that you, I guess, may need, not must need. If you're selling small packets, I don't think there's an issue, I guess. Does that make sense to you?
I'm trying to say in the general case there are certain SCTP specific parameters.
Yes, there are SCTP. The only one that we have right now is the max packet size that I'm aware of, but potentially there might be others.
But those aren't necessarily SCTP specific. Those are like sort of data channel specific. You need some sort of callback for indicating that a data channel has been created. We need some sort of way of finding out what the max message size is for data channel. But those could easily be on a non-SCTP transport as well. I mean, I totally agree. This should be in something other than the DTLS transport.
Right. So in the future, you could have a different kind of transport with the same methods.
Yeah.
Yes.
So, I mean, right now, right, the max message size is on the SCTP transport. So you're saying, Justin, maybe there should be some properties on the data channel object?
Well, not necessarily. I guess we're just sort of talking about some idea of having abstract transports in the future, and I just wanted to see like how much are we coupling ourselves to SCTP transport here. And then will we have some other interface in the future of an abstract transport that had like a max message size and on data channel parameters, but then like SCTP transport was a descendant from that interface?
I think we could certainly do that in the future.
Yeah,
I just don't see. We're not pinning ourselves into the corner right now, but there's not.
No, I don't think so. And I could see other types of. To be honest, I don't know if what kind of transports are necessarily going to exist. I mean, this is a very packet-based transport or blob-based transport. I could see more of a stream-based transport coming up too. And I don't know that kind of object hierarchy. So although we've got direct wiring between the data channel and the SCTP transfer, I do foresee a future where we're going to have different kind of base transport objects which will have different kind of implementations which we could wire to. So I don't see that as a harm wiring it to the SCTP transport for now, and then potentially replacing that with a base transport in the future for the wiring.
Okay.
Okay. Next slide, unless there's somebody who has any other comments. So the issue here, which is related to the previous issue, is that the RTP and RTP receiver objects, those are the things that you're going to take a media stream track, and you're going to wire it to an RTP sender and RTP receiver so that you can describe how the media goes over the transport. Right now, those objects are directly wired to the DTLS transport objects. Again, in the future, you might have an alternative to the DTLS transport. I don't know what kind of transport, but I'm sure that they're going to exist, or some people have specialized cases. And the idea here is that when those transports get defined, we will create a base class that represent that DTLS transport, which we'll derive from, and instead wire the RTP sender to that base class as opposed to the derived class. So that is our strategy on how we intend to future-proof this. Right now, we don't have any other classes for transport, so there's no need to create the base class. But when we do, we will create that base interface to derive from for the DTLS transport. Does anybody have any concerns or issues regarding this?
Well, it's not a concern for a browser use, but for a gateway or server-side Node.js, it seems like there probably would be alternative transports off the bat. Like, something that, like a gateway that takes WebRTC on one side and, spews out SRTP as DES, or maybe RTP in the clear on the other side to talk to legacy. So some guidance about how to do something like that, whether you use an alternative constructor or something else, might be helpful.
Yeah, I think we should then definitely make mention of this in the specification, that this is the intention, is to create a base class, even if we're not going to do it right now. I just don't want to create the base class interface right now because we haven't seen the need as to what has to go in the base and how the base should properly be described at this moment. So I'm a little bit fearful going down that rat hole without some real use cases in our lap.
Yeah,
so,
it could be confusing trying to handle both the browser case and the server case in the same spec.
right.
Because you'll end up doing stuff that a browser probably shouldn't do, but some guidance about how it should be done might be good.
Yes, and there might be, and as far as non-RTP transports, there's other transports where you might have to describe things very differently. So you might not even wire to an RTP sender and RTP receiver. So those are the kind of objects issues we might run into, and so I'm a little bit hesitant. But yes, that's a very valid point. Is there any other comments or concerns? Eric, I'll need you to mute, or Bernard, I'll need you to mute because okay, got it, thanks. Okay, next slide, otherwise. Okay. So issue 31, which is the big meat and potatoes one that I really want to get to, is regarding how to describe those RTP sender and RTP receiver objects in terms of all the descriptive objects that we're going to contain, mostly are structure-based or object-based, however we want to do it. Google has come up with a proposal on how to do this. I think it's a good proposal. Other proposals are certainly welcome. Some things to keep in mind when we're discussing this, and I just want to qualify this, is that we're trying to achieve certain sets of goals with this, and Peter's come up with a list of use cases that I think are useful. Just to reiterate some of those issues. One is we want to handle obviously the basic scenario of a simple audio and video stream, or multiple audio and multiple video streams. Those are simple scenarios. We'd like to be able to handle simulcast, which is the sender is sending multiple streams out, but the receiver is only selectively receiving one of those streams because it's going through some kind of selective forwarding unit of some type of thing like that, or a multicast or simulcast server, or being able to receive multiple simulcasts from the remote party. For example, if you're receiving a full stream plus a thumbnail version or something like that. So that's another thing to consider. We also want to be able to handle layering. That's a goal of ours, so that when we have temporal or spatial layering going on, and I'm not an expert in this area, so I'll delegate that to other people to speak about, but the idea is that you can describe it correctly and how all the layerings are to be subdivided in this description. Obviously the codec stuff's got to go in there. And targeting for the engine. There is a separation between the media engine and the JavaScript, and the roles of each that we want to define. JavaScript may not be fast enough to handle on a packet-by-packet basis. So you can't have a callback on every packet. How do you want to handle this to know what kind of encoding you want to use and all this other stuff? So you can go completely crazy, but JavaScript really isn't fast enough to really handle that under most scenarios. What you really want to do is you want to describe some targeting that you want the media engine to do. For example, resolution or scaling or quality or other metrics, frame rates and all that kind of stuff. You describe that to the engine and maybe have some callbacks so that you can, or as many callbacks as you can allow without overloading the JavaScript, and also to make it so that people don't have to implement those callbacks to have a reasonable set of default behaviors that they should expect when they instantiate the RTP sender and receiver objects. So keep those kind of issues in mind when we're talking about it. And from here, I think I'm going to hand the conversation over to Peter, since it's his proposal from Google. So I welcome him to the stage, and you can mute me, Eric.
All right, so as Robin was saying, we're trying to focus on the use cases. And the email I sent out, rather than explain each use case, I just gave examples of how what we proposed would meet the use cases. And there's been some discussion already on the list of different things we might want to tweak, especially around how to control the quality versus the frame rate, or how you want the system to respond, how to configure the policy basically. And for a lot of them, I've responded and said, can you please come up with a use case, because whatever proposals we have are variations of the proposal that we come up with, and we've already come up with many different variations. I think we're going to be most successful if we compare it back to the use cases and see if we can meet them all and how well we meet them all. So anyway, this is in one slide basically the configurations that we would like to be able to do on a per layer basis. So in a typical one-to-one case, when you might only have one layer, but in a simulcast case, you might have, say, 3. So at the top, we have the different pieces of information that you'd want for the layering, whether to keep the layer active or not, and then the dependencies between the layers. So if you're not using a layered codec, the dependencies wouldn't matter, but if you are using a layered codec, then they would matter. And if you're not doing anything where you're turning on and off layers, then the active wouldn't matter. But using the active field would be better than, say, removing the layer entirely from the parameters so that RTCP can keep functioning and resources in the browser can be allocated so that when you turn it back on, it doesn't take a long time to come back. So there hasn't been much discussion on the list so far about that. Mainly the discussion has been on the things towards the bottom. And so, like Robin was saying, we want some way for the JavaScript to be able to tell the browser, here's the kind of things that are important to me, and then as more bits become available, or as less bits are available, do different things. So one of the important things is to be able to have some kind of priority between the different layers and even between different RTP senders. And so that's what the priority field, the first field you see in the middle there, the priority field is. And it basically means as more bits become available, allocate them to this layer or that layer, and it's done proportionately. I think everyone on the discussion so far on the list has agreed with that sort of approach. The more of the discussion has been with the others around quality and bitrate. Although,
Peter, I had one question. In layered coding, you can apply RTX or FEC to a given layer, and so one thing I wondered is something like that appropriate in this structure or somewhere? How do you apply things to only one layer?
the very top where it says existing codecs and header extensions, etc. So one of the existing things is already the FEC and the RTX.
Oh, okay. So that would be there.
So I only included on the slide the stuff that's proposed to be added.
Yeah, and we might want to have some control over, exactly the amount of FEC we want to apply. There's some questions about whether we would want to have FEC sort of do automatic things here. Like if you know we're doing unlayered encoding, will we only want to apply the FEC and RTX to the base layer? That's stuff we have to figure out as to how many knobs we want to expose there, how much should sort of automatically do the right thing. Right now we're sort of biasing toward exposing the fewest knobs possible, just to avoid having circumstances where you can turn knobs into regionally inconsistent configurations.
Okay, so what we have proposed here includes a couple mins and maxes, and then what we call the bias, which is basically what do I care about more, resolution or frame rate? And discussion on the mailing list so far has been like, well, do we need this max? Do we need that min? Do we need another max, another min? Do we need mins at all? And then rather than a sort of 2 or 1-dimensional resolution versus frame rate, do we want a 3-dimensional resolution, frame rate, quality? And so there are just different variations on what knobs ought to be available here. But everyone seems in kind of agreement that we want some knobs to be able to dictate the policy, but not specify a specific resolution or a specific quality. You just kind of tell it what bounds to work in and what kind of policy as far as what's important to you. So maybe it's more understandable if we go to the next slide, which has a couple examples. Yeah. You probably have to check the email. I only made one slide, and there will be more examples that could fit on one slide. In any case, a normal one-to-one video call would be very simple. You wouldn't have to configure anything. Things would work automatically. But if you wanted to say crank up the quality, then you could have some way of cranking up the quality. If you had something like sign language where frame rate was a lot more important, you could say bias towards frame rate. And if you had something like a screencast where you don't care about the frame rate so much, but you really want the high resolution, then you could say bias towards high resolution. And then there are more use cases not included on this slide. You can check the email that I sent out.
The next slide has the SVC.
Oh, okay. Oh, you broke it up.
Yes.
All right, so for simulcast, you give several different encodings. And the key here is that when you're doing simulcast, you do not specify the resolution, you specify the scale. If you want to control the cropping or the aspect ratio or all that kind of stuff, then you would control that out the track, not in the encoding. And the reason why this is very beneficial is, number one, we already have control over resolution and stuff on the track, so why have it in the second place? And number two, if the resolution or crop changes, for example, when the camera rotates, there's no reconfiguration that needs to happen. Everything can just work. Plus, it's a lot easier to specify. As you can see, the example is pretty short. You just say, I've got 3 layers. I want full size, quarter, and 16th. And then for the case where you have dependencies between the layers, then you would be specifying those layer dependencies with the layer IDs.
I think we should also mention, sorry to interrupt, Peter, that there is some discussions whether we should have one RTP sender that for simulcast or multiple or one RTP sender per sizing for simulcast. There's been some discussion on the list about that too.
That's true. So it's always possible for the application to create 3 RTP senders. The question is just whether is it beneficial enough to support having one RTP sender with multiple encodings for us to include support from it. So there's still some discussion whether that's worth it or not. I think it is, but it has been a point of discussion on the mailing list.
Right, and the key thing that needs to be sort of taken into account there is when you have multiple RTP senders, that means you need to have multiple tracks as input. which would mean you need to take the input, clone it, and make your multiple tracks. And on the receive side, if you have multiple RTP senders, each one of those is going to be emitting a track as well. So cases where you actually want to have different tracks and you want to display different tracks, it makes sense to have different RTP senders and receivers. But if you really just want to have one track and generate multiple encodings, we think this approach is more streamlined.
I think that makes a lot of sense. I agree with you on that one. I got a question though for you guys. Looking at this slide, how would someone specify that they want to do simulcast versus layering? Like, to me, the encoding looks identical. So how do you know what you're actually doing?
Well, the only difference between simulcast and layered encoding is the fact that the layers are dependent on each other in the layered encoding. And so you see here the layer dependencies. The fact that one layer actually depends on another layer is the indication that it's actually supposed to be doing a layered encoding. That really is, I mean, at the actual encoding level, that's the only real difference, is the difference between, like, inter-layer prediction or no inter-layer prediction. And if you have no inter-layer prediction, it's really the same thing as a simulcast.
So if you want to do layering, you must specify the layering dependencies then.
That's right.
Okay.
I had one question about the simulcast, if that's all right.
Sure.
How would different frame rates work with simulcast? Will they also be dependent on each other, like 50% of frame rate or 25% of frame rate? Or can you just set totally different numbers there?
So we didn't do anything. It's not clear to me exactly what the benefit of doing the different frame rate. Are you talking about doing a different resolution with different frame rate for the simulcast?
Yeah, like for example, a thumbnail image with 1 frame per second or something like that.
Right. So we had another example, and we kind of dropped it off here just to fit it, so it all fit on the slide. But in the case where you wanted to have, a different representation, you could have another encoding that was, this gets back to the question of should this be a separate RTP sender? You have another representation that's really substantially different than the main representation. Should that be a separate RTP sender? We could put another control in here of having a frame rate throttle where we scale the frame rate down the same way we're scaling the resolution down for like the configuration. We left it out of this just to try to keep the number of knobs to a minimum.
And sorry, go ahead.
So I was like, you could do this by creating a second RTP sender. We would need to add another knob here if we wanted to do it within a single RTP sender.
But then you would lose the efficiency that you were talking about a minute ago, right?
Well, you would, except now, like you could maybe consider that this 1 FPS thumbnail might be a very different, actual thing that you want to send than like the mainstream. That distinction might be artificial.
It sounds though, from what I'm looking at the encoding, RTP encoding parameters, we don't have exact sizing anyway in there. And as you said, you want to do that outside of the RTP sender. So to me, if you wanted to say, I'm going to have my thumbnails at 60 pixels by 60 pixels, you would want to do that outside in its own clone track and have two different senders. Am I correct, or am I misunderstanding?
That's what I'm suggesting, yeah.
I don't have an issue with that, but maybe others do.
I think the real thing here is to get the use cases. If you find that the API fits the use case as well, then it's probably a pretty good indication we're going the right way with the API. If we find there are use cases that are important that we have to like bend ourselves into weird shapes to actually do this with the API, we probably need to take another look at do we need to add some more knobs.
I think for the layered part, you do have some of that concern, because typically don't you have different frame rates for different layers, and you want to be able to control those depending on what the application or how the enhancement layers sort of stack on top of each other, depending if it's temporal versus spatial.
Well, the spatial all stack have the same frame rate, because you typically don't want to have really complicated prediction structure, and typically the actual spatial layers all have the same frame rates. We've omitted the the knob that sort of controls the temporal scalability here, and this is actually something that we didn't have on the slide before. It should have been there. But basically, the plan for the temporal scalability was to have sort of an on-off knob for the temporal layers. And that's something where I think trying to have too much manual control of that is probably just going to make life hard because there are the actual right configuration for bitrate allocation between temporal layers is pretty hard to get right and have it be efficient. So we are, my suggestion is that we...
Yeah, I agree with that. In all practical purposes, most implementations don't go as far as doing both temporal and scalable and, making fancy things. So, but you may have to make that explicit that, or just ignore it until, say, the issue comes up, I guess.
Yeah, I think what we need to do actually here is have just some value in the number of temporal layers to use, which is by default 1.
I guess I also had a question about the use in the bias of resolution or frame rate, and I didn't know if the implication of resolution was a quality metric or it was actually the pixel resolution. Where I guess my interpretation was that like your rate control is changing resolution on the fly versus adding more frames, or I'm just used to thinking more about picture quality versus frame rate. Can you explain that?
Right. So basically we have this notion of like what minimum we consider the minimum QP, or sorry, maximum QP that we want to be able to sustain is, and that if we now get to a point where we can no longer sustain that QP, we have to do something to basically get our bits down so that we can fit under the amount of bandwidth that we have. And the options we have are either to reduce frame rate or to reduce resolution. And this bias will give us a hint as to which one we should do first. So we're going to be scaling QP, as to fit the available bandwidth. And then when we find out that the QP scaling is insufficient, what we should do instead at that point in time. Should we back down the frame rate or back down the resolution? And
are you assuming a constant QP, or are you allowing rate control to take over?
No, rate control is going to be controlling the QP, but we'll get to some threshold where we say that we're no longer able to deliver a QP that we think delivers adequate QoS. So we need to do something else to the stream in order to make sure we're delivering a decent picture. In that case, backing down frame rate or resolution seems like the right thing to do.
But wouldn't it make sense to signal the application to then go up and change the scale, at an application level? So in other words, the fine grain or the coarse grain control of resolution sort of happens, very, it's not going to happen all the time. Hopefully it's just, once in a while. And that seems to be something that the application might want to control.
Yeah, I mean, that's one way of doing it. One might imagine that you would want this you'd want to have something that works well even for applications that are not sophisticated, where you just have, you captured 720p, you try to send it over the wire, and if it turns out that there's not sufficient bandwidth, that you want it to intelligently back down to 540p, 360p, whatever, to properly fill the whatever space there is in the pipe. And
yeah, I get that. I mean, maybe it'd be nice to have both scenarios supported, where if I always, for some reason, always want a certain resolution and I don't care how the quality goes, that's one scenario. Or the sort of dumb mode where do whatever it takes to give me a good stream, whether you're change resolution or not.
I think to add to that, Chris, there has been some talk on the list, especially regarding max and min, that perhaps when it reaches the various min or max thresholds, that there would be a callback event to the JavaScript layer that then could handle it and know what to do.
Right, that's what I suggested.
Yeah, that's what you suggested. Good. Well, I'm bringing it up. The other thing is that the bias, I think someone suggested that the bias should have to perhaps be a sliding scale instead of just an all or nothing from a real number from 0.0 to 1.0 and just a sliding scale. That's it.
Yeah, I mean, we could definitely do that, and that was Peter and I discussed that as like a temporal spatial trade-off parameter. We ended up going this way for simplicity, and as Peter mentioned, it's not clear like what would a value of 0.2 actually mean. Because these are sort of hints to the encoder as opposed to like specific settings. That being said, I think we can come up with things that really indicate what the behavior should be in like a 0.2 setting. We can take another look at it. It's not.
I mean, maybe it's a sliding scale from picture quality to frame rate, and then you have like allow resolution switching or not resolution switching. I don't know, something like that. Because I think there's sort of orthogonal components to resolution and picture quality. I get that, it's sort of like the nonlinear part of the rate control where you switch from pushing as many bits for X resolution to changing resolution, and then your rate control, sort of resets itself to that new resolution. But
if you want to lock in the resolution, that's what the scale does. So if you said scale 1, that would mean don't change the resolution.
Well, no, because the scale won't lock in the resolution. It'll still be, it would be, affected by the need to back stuff down.
So it sounds like you might even need a min-max scale to achieve that. So where you could set them both to be the same value to lock it in.
Yeah,
I missed the default is unconstrained part of scale. So you're saying if you don't include a scale value, then anything can happen. If you include a value, then it must be that.
Well, that wasn't my intention. I think the scale is really for showing that the relation between different encodings and that we needed to back down due to bandwidth pressure, that we would back pretty much everything down.
You back down all of them together, is what you're saying. Oh, so it's a relative. There have been a lot of variations on, well, what about this knob? About this knob. So I think the best thing we can do is, if we think of a use case that's not already listed, add it, and then if we think of variations that would be better, then come up with examples for each of the use cases, and then we compare the examples and say, okay, this set of examples is better than that one, so we like these knobs better, or something along those lines. That's the way we've done it so far, and how we ended up where we are.
Yeah, I think my comments are less about the use cases and more just about the dichotomy between resolution and picture quality, and whether that implies the same thing, sort of at a not sort of a general level, or do we really want to call out those and make it more three-dimensional, graph of 0 to 1 parameters to define?
Yeah, but the problem is if we start making some three-dimensional space.
Yeah, I agree. Yeah, it's not good.
How that's going to be implemented. I feel like there are some specific things that people want to do, and those don't require coming up with like a multivariable optimization type of problem.
Yeah, absolutely.
But I do think there's two separate sort of things here in these parameters. One being the simulcast / layering, and one being the kind of control between like what we want to do for rate control between max quality and max frame rate. We probably should address these independently as smaller problems, because I feel like they're mostly orthogonal. That how we want to deal with resolution switching in a bandwidth constrained situation applies. It can be scoped entirely to a one-on-one call situation. And I think how do we set up a simulcast, it ends up being completely independent of that. So rather than trying to deal with all these parameters at once, we can probably try to look at those two things independently and make more progress.
I had a question about this specific example for the MST case. So you're saying each layer from a separate RGB sender, but how would you express the layer dependencies? Or is it possible to have the SRCs be different in this encoding object?
Yeah, so the SRCs could be different. Is this one just being an SST? I had them all be the same.
You mean single session versus multiple session, as opposed to single source versus multiple source?
Yeah, that's what I was. SST is single session, and each RTP sender is a different session.
then you'd need a different RTP center. Okay.
Yeah, right, exactly. So, I mean, that's another way of thinking about the RTP senders, is that each RTP sender basically corresponds to a different session, whereas different encodings within a single RTP sender are just different sources within a single RTP session.
Just sorry, I'm going to add something in here. One of the issues that brought to the list was regarding predictability. So the idea here is that if someone writes a piece of JavaScript code and we have different implementations, we got a server implementation and a browser implementation, in theory the engine should work in a predictable manner. So it'd be also nice that I don't know how much predictability we want, just to say, look, it's your interpretation on those parameters versus us dictating this is what it means when you sign 0.2, right? And this is how you would calculate that.
Yeah, well, that's what seems hard because we don't have any specs or anything that we can point out and say here's what 0.2 is defined to mean. I feel like, you know, in terms of what we actually encode, you know, in terms of RTP and layer dependencies and all that sort of stuff, we can get that all working, all defined, and have that be predictable. But I do think that a lot of the rate control stuff is still very implementation dependent and unlikely to be standardized in the, you know, immediate future. And so
I think it's fine. I don't think there'll be any issues. I mean, as long as it's, you know, you're consistent on one implementation, you know, you're the sender, so you're doing what you need to. And I don't see any issues there.
I'm just more thinking of in terms of somebody writing a generic library, Chris, and expecting that the behavior when you write this library is going to be very consistent. If you were to throw it on a server versus throwing it on a browser, that the behavior and what your output expectations were would be consistent.
Right, but the point is, you know, just to echo what Justin said, you're never going to get two different implementations of rate control to act the same way.
I agree. I tend to agree.
So maybe there's like a delta sort of convention of like where you should be or some guidance, but that's about as good as you're going to get, I think.
Yeah, guidance might be good. And obviously the different codecs you use could influence things dramatically as well. So.
Yeah, just one question. I mean, there are scenarios where you'll have, for example, be simulcasting different resolutions. Within each resolution, there's temporal scaling. And so I think from what you've described, there's no real way to describe the overall behavior between all these different things. But that's probably okay. I mean, you wouldn't necessarily specify, for example, a frame rate versus resolution trade-off in a temporal in a temporal scaling object.
right, and that's one thing that I kind of wanted to try to steer clear of having like different parameters for each, in a layered encoding scenario, having like, substantially different parameters for each layer that were sort of mutually inconsistent. For simulcast, like you could have something like that because they really are like separate streams for the most part. But you know, I think that in terms of implementation simplicity, the more these things apply to like the streams as a whole, as opposed to like this thing is going to get 40% of the bits and this thing's going to get 35% of the bits. It's going to be very difficult to have that fine-grained control and actually have that work in all scenarios. I mean, I think really what we want to have is knobs that allow people to do simulcast, knobs that allow people to do layering, knobs that allow people to basically expose the intents to do things different for different scenarios, and not let people like have enough knobs that you can set things that you get unpredictable results.
I was curious. I was a little curious about. This might be going back a little bit. For the simulcast case, if there is a resolution switch, is that anticipated to be simultaneously on all streams? Like you have your full resolution and your half resolution. Are they both going to switch to half and quarter at the same time, or do we need mechanism to support that?
Yeah, so I just think about that a little bit more. It might make more sense in that case to actually back down the resolution by telling the track to change its resolution, because that would then have everything work in unison. And what you might have in the other case would be that if you don't have enough resolution to send, the full resolution layer, then maybe just starts sending only the medium and smaller resolution layers instead. And so you have this kind of staircase type thing where, as bandwidth increases, you start out by sending just the base, and then the base and the enhancement 1, and then base and enhancement 1 and enhancement 2. And if bandwidth disappears at some point in time, then you're back to just like base and enhancement 1. And then that should be pretty easy to express, I think, using the constraints that we've put out there already.
Yeah, that makes sense.
And that could be something then that, in a single stream case, one-on-one situation, you could then, if you're bandwidth constrained and hitting like, a QP threshold, you as the application could then back down the resolution yourself to make sure that you're getting the desired, QP. But I think we need to probably work through these. I hadn't really been thinking about that previously, so we probably need to rethink about that through the examples and see what the problems.
And we're coming up on an hour here, guys. Just to.
Yeah, I think this is a long discussion. This is a very complex area. I think Peter's given a good overview of it. We probably should move on, and then I try to tackle some of these things specifically on the list.
I just also want to comment that this is a very nice proposal. It's good that we have something concrete to sink our teeth into and argue about the little individual parameters in here, but overall I really like it. And I certainly welcome everybody to beat up on the details on the list, and let's try and hammer out what those knobs should be, keeping in mind, let's keep it simple for the simple use cases, but also allow the kind of flexibility we need, and hopefully allow the application to control most of the weird situations as opposed to putting knobs for weird situations. So that's all I have to say on that.
I concur with it being a great proposal as well.
Okay, so what I suggest we do is, why don't we finish off one more topic, and then we can come back to this after and see if anybody has more input. And so I just want to get this one little thing out of the way. I think Sylvia was the one who suggested that we might want to change her name, but she's not the only one. And the issue is that there's some inconsistency between ORCA and ORTC and confusion regarding that, first of all. ORCA is the name of the community group, ORTC is the name of specification, and ORTC stands for Object Real-Time Communications. ORCA is just a branding name. Because ORCA already exists as another project, and there's other things that have claimed that namespace, so it might be better if we just put everything around the ORTC name and change our ORCA name. And Michael Champion, I believe, has looked into how do we get that done in a technical level, and can we do that, and what the issue is. So, Michael, do you have anything to add on that, aside from asking people whether we should do this or not?
No, other than that, changing the display name is easy. Changing the URLs is, has more fundamental implications. In W3C's point of view, the URLs are the real fundamental identity of something, and they shouldn't change. So I'm not sure we can change the URLs to remove the ORCA word without essentially creating a clone of the working group. But changing the name is easy, and I certainly recommend it.
So our options are creating a brand new community group with the ORTC name, just renaming the ORCA community to ORTC, but leaving the URL on the W3C alone, or doing nothing at all and leaving it as ORCA. So,
well, I don't think that's quite accurate, Robin.
Okay, please.
I think that those are certainly choices, but changing the URL shouldn't be stricken from the table. I don't think it's as difficult as has been made out. I think that it's a bit more basic than that. I mean, I don't think it's that that difficult. It's probably more of a political thing than anything. So I think
I wouldn't disagree. Yeah, I'm sort of not wanting to have that political fight with W3C, but yeah, if that's the right thing to do, we can have that fight. I agree.
And I think if we're going to do that, we'd be better off doing that sooner rather than later. We don't want this lingering and have all these pointers to a URL. And we should make sure that the old URL is pointed to the new URL, at least for a duration of time.
That would be the ideal outcome from my perspective. Change the thing, have the old ORCA redirect to ORTC, and then after some period of time, like, everyone will just be using ORTC. If that's hard, I would just say, like, do all the branding changes and just leave the URL. But
I could see the mailing list being the problem more than the URL.
I mean, I don't think that many people care all that much. As long as we refer to it as ORTC pretty much going forward, the fact that ORCA is used in some URLs now, that's hard to change, shouldn't be a big issue.
Just a quick question about the supposed life cycle of this community. Is it the case that in the best case scenario this would eventually disappear and fall into the WebRTC group?
Are you referring to the working group, Emil?
Yeah.
You're talking about the existing WebRTC, not a new one, I presume.
Yes, I'm talking about the existing. If this becomes the new way of doing WebRTC, is that we're going to continue within the WebRTC group, or?
That's W3C's model of how community groups work, is that when they produce something substantial, they transition into working groups or contribute their spec to a working group. Whether that's what this group wants to do is another question.
And if it's an existing working group or a new working group, I think that's the other question.
Yeah.
I mean, the community groups are an experiment, a couple years old now. There's, we can tweak. We W3C. I'm on the advisory board, which sort of owns the process. Can tweak the process to make it work better, but the more and more they're in parallel, where often there's a community group that's kind of the experimental lab for a working group, and when ideas get a lot of momentum, they go over for a more formal standardization if the participants think there's a strong reason for that. So we can go either way. I think it's really what the community group thinks, and I don't think we need to make that decision now. I think once we have a stable spec that it's broadly implemented, or broad proof of concept that it's implementable and does all that we hope it does, that's probably the time to have that conversation of whether we want to try to get the working group to take it over, or we want to continue as an independent operation.
Right. My question was mostly in regard to the name change and how much it would matter. But yeah, apparently it's not as simple. So disregard.
Yeah. I guess really what it comes down to, it's when we come up with something, it's up to them as well as up to us what we want to do. And do they want to, for example, adopt this as a 2.0 cycle that they want to go into, and we're okay with that or not? I think it's totally up for debate, and perhaps a little premature to... We have that option, but it's perhaps a little premature to discuss if we should follow that option right now.
Yeah.
So
this is Bernard. I would advocate changing the name. But the other thing I'd say is, there are other uses of ORTC. So there's like an object, another ORTC abbreviated API. So just keep it in mind. Eliminating all the conflicts may not be easy or possible.
Yeah,
very valid point.
I'm aware of that, and I agree.
So I don't know what it comes to, like this to me, I don't really have a strong opinion one way or the other. I would rather kind of like to hear what everybody wants to do, and then I'll, see to making sure it gets done. So you know, what do people want? Do they want to change the name? Do they not?
Well, we've had members of our community group request that we have this discussion, and we've other members of the W3C and other working groups and community groups are working on similar named technologies. So I think the question is you know, are we going to change the name, and does ORTC represent something that we want to change it to? And I am for changing the name for the reasons I've already stated.
I agree as well.
I'd be happy just so that we have only one name instead of two.
A good point.
That's my leaning as well, just to avoid two names.
Yeah, avoiding two names is a good thing for me too.
Sounds like we've got consensus, I would say.
Yeah, if there's anybody that's opposed to it, please speak up. If not, we'll go forward with that. And Michael, I'll work with you to work through the finer details of getting that, making that happen.
Okay, sounds good.
Okay. So if there's nobody else, we can go back. Oh, there's one more slide, which is at the end here, which is just the thanks. And I thought I'd point that out before we go back to that, because I don't know when people are going to have to start dropping out. Just wanted to thank everybody on this list, Bernard, Michael, Justin, Peter, and Martin and Eric, for the tremendous amount of work that you put into helping the specification, helping develop the technology, proposals, everything like that that you guys have done. Awesome job. Thank you very much. Really, really appreciate it. And keep up the momentum. This is amazing. And without further ado, let's go back to discussing the meat and potatoes. If anybody wants to continue, I think it's slide 20.
Oh yeah, I think we're pretty much over time at this point. Probably should take this to the list.
Sure, I'm fine with that.
I think that there were some specific items that we addressed, specifically Justin, in conversation with Chris. So maybe you guys can, take that to the list specifically.
Okay.
There's also one thing I wanted to mention before we go, and that has to do with that we're not just targeting browsers. Everybody should remember that the target is browsers, mobile, and possibly server. So with that, for example, there are some differences. A server implementation might not have GUM. It might have a different way to get tracks, or tracks just might emit from this thing. So some of the controls might not exist, so you might have to have equivalencies on the server side. So just keep in mind that we are targeting those three areas with ORTC, and it's not just browser-based technology. I forgot to mention that earlier.
Yeah, I have a question which we don't have to get into now, but it's just a general one, which is we've been adding a lot of this configuration stuff, and it makes me wonder whether it has implications for the capability discovery as well. Because I've been kind of going through it, and I think we may have gotten ourselves a little bit inconsistent there. So just something to maybe, as we get a little bit further along, just check the RTC capabilities to make sure we can discover everything that we can configure. Like, as an example, like discovering the number of layers you could support, or whether you have support for different types of scaling, stuff like that.
That's a good point.
Yeah, because I'm assuming we're not dictating that you need to support any particular layered codec or simulcast or anything like that, or will they be
right, or even to the extent, like as a weird example, like a particular implementation of a codec might or might not support certain feedback messages. So anyway, just something to maybe go back after we're a little bit further along and just make sure we can discover everything.
Yeah, that makes sense. And even certain implementations may not support, say, spatial scalability for VP9. So that would need to be something that whether or not you can actually pass in a layer dependency that it'll actually be processed properly.
And also, how do we handle errors when they do things that are illegal in that regard, too? Okay.
That's right.
On that note, again, thank you everybody for coming. And if there's anything that somebody needs to say right now before we end this call, please speak your mind and not forever hold your peace. You can go to the list to say your piece as well. Thanks for everybody for coming, and that's it otherwise.
Thanks, Robin.
Thanks for hosting, Robin. Thanks everybody for joining.
Thanks, Eric and Robin, for driving this.
No problem.
Thanks for making it happen.
Thanks, guys.
All right.
Thank you.
Bye.
Bye-bye.
Yeah.